Get your paper out already and you're ready to go. Someone's alarmed. Okay.
Wait, what the?
First of all, though, before we start, how was break? You guys make it?
Yeah.
No?
Wait.
I have. Now, don't write them down yet. I'll let you know when to start. I have 4 problems. Compare and contrast for me real quick. What are the similarities of these 4 problems? They all have X's, they all have Y's.
1 and 2 both have negative numbers, and then the bottom 2 have positives.
There's some patterns like the negatives and the positives, possibly some similarities that way. But what's something all of them have? X's, Y's, equal signs, and how many equations?
2.
Interesting. Each equation has 2.
Every pair of equations, whether it's 2 or 3 or 4, which thank goodness we're not going to have to see 3 or 4 for a while, but every time you have more than one, it's called a, do you guys remember? System. Why is more than one? Why do we need, do you remember? I don't know if you actually talked about it. Why do we need more than one equation? Find X and Y. We have 2 variables. If we're missing X and Y, we have to figure out from 2 different equations how to find the 2 different variables. Can anybody give me an example of some sort of problem where you would only need one equation to solve? Yeah.
X equals 2 plus 10.
Sure. X equals 2 plus 10. Or it could have been like X minus 2 equals 10. Same problem, right? Because if the 2 is on the other side, you only need one equation, right? Because you only have how many variables?
1.
Yeah, no big deal. Those were the easy ones. The easy days of maybe like pre-algebra, math 7, math 6. But, sadly, these are harder. So then we need to have ways of solving for 2 variables with 2 equations. And the very first way in section 5.1 that you guys talked about solving was, if my marker could be not absent. Actually, that was the third one. The first one would have been, it's not there. Oh, I'm struggling. My marker's missing. There we go. Graphing. Let me go find my marker wherever I put it. The first way you talked about was graphing. What's the second way you guys talked about? Do you remember? Section 5.2?
Substitution.
Substitution was the second. And then, I think, was it you, Jordan, that said it earlier? Elimination was the third. So why do I have 4 examples? Well, you guys did have 4 sections, but actually 5.4 was just like a, hey, funny stuff can happen and maybe all these numbers or all the variables go away. So instead, for my 4th one, instead of talking about all the special cases, we're just going to say, hey, let's do one more example where you guys get to choose your favorite. Okay? But let's review the 3 main ways of solving. All right, time for notes. Let's review the 3 ways of solving. By graphing, by substitution, by elimination. And you have one example to be like, which one's my favorite? What would I think of doing for this problem? Then we're done. 4 examples. Then we're done. Then oh, but we haven't done. Oh, don't worry. We're going to solve all together. We'll solve all together so you need to review. All right. How do we graph? We have to get these things in a form that we like to graph with. Graphing lines. Do you guys remember how to graph lines? There's a certain form we like. Do you remember the special formula?
Y equals mx plus b.
Got it. We like that. If we have y equals mx plus b, okay? We have 2 pieces. We have b and we have m. Do you remember what each piece stands for?
Slope.
M is slope.
Good.
And b is y.
B is
Good. Way to work together. M is slope. B is y-intercept, right?
Yep.
Slope. Rise over run. Y-intercept, where it's the y-axis. Remember? Intercept, intersect. Okay, so when we go to a graph, once we have all these pieces, we'll be able to mark the B. Now, I'm going to make up a B for right now. We can mark the B, then we do a little rise over run sort of action, and then we say, hey, there he is. Right? But how many different lines are we graphing for this example? 2. And what are we looking for the solution? Where they intersect, if they do at all, yeah? Okay, hold on. Check out real quick, because this is an all for one, one for all sort of deal. Check out your pals next to you, or maybe they're not pals, but still you should be looking out for each other. Is anybody nodding off? You just need to elbow real quick. Peek, peek, peek. There we go. Coming back. It's the first day back, right? People are gonna nod off. It's a struggle. Just look out for each other and give a quick little. Right? If you're sitting next to a friend in church and they start snoring, you can just laugh at it. Elbow them a little bit, right? Okay. Question: are they ready to go?
I'm ready to go. No.
They're not ready to go because who's not alone yet?
Why?
Yeah. So you need to get Y alone. How?
Why?
Subtract X.
Good. You guys working with the first one? Start one at a time.
Yeah.
Negative X.
So we need to get Y alone. Let's go ahead and take this one over. And I heard a lot of minusing X's, subtracting X's, yeah? Okay. So if we subtract X from one side, what do you do to the other side? Keep it balanced. Subtract to the other side. Now how do we write this nicer? That's not
9.
right. Careful, not 9. Good idea.
Negative X.
Yeah. Why can't we put these two together?
No, there's no X in this one.
Good. So this doesn't have an X. They're not like terms and I can't combine. So we have to keep them separate. And Jordan, why did you put the X one first and then the 10?
Y equals mx plus b, so you have to keep it in the same format.
Perfect. We need to keep it matching the formula. So the X part came first, the minus 10 came second, and we can't combine. This is ready to go, but we need the second one, right?
Yeah.
Okay, so hold on. Let's go to the second one. Let's bring him over.
Ooh. Do it again. Y.
Do you want to move the X?
Yeah.
Okay.
Negative y.
Negative y equals X minus 2.
Now, when you guys are saying that, doesn't something sound kind of funny?
Negative y.
y.
Yes, but change y equals x
Yeah.
plus 2.
Divide by negative.
So we're keeping that X part first again, right?
Divide by negative.
Good. Now, is there technically another way besides dividing by negative 1?
Just by negative.
Yeah, you could multiply by a negative, you could divide by a negative. What's going to happen to all those signs when you do that?
Positive.
So we're going to end up with a positive y equals a positive x and a plus 2. Good. Let me go ahead and go over here and zoom out real quick. All right, let's put these down just to not be doing goofiness, huh? How do I take these two equations and put them in a graph?
So you go on the y. So you go on negative 10 and well, if you do the first one first.
Good.
The lines over 10 they can just honestly.
Take practice, but don't worry, I'm gonna make lots of mistakes. You guys have to. We'll work together, yeah?
I was giving you a hard time. That's what we did.
I'm take it.
Maybe you felt like you died. I mean, like what we used to do with the.
What else do you say though, right?
You're an artist.
It's okay, he missed you guys though. You saw him come over here. He's checking on you. He'll keep doing that.
We actually forced him into
He brought him in. Okay, question? Okay, so we started using negative 10 because Jordan touched the first one, right?
Yeah.
Now what?
Down 1 over 1.
Stink. Down 1?
Yeah.
Okay. So down 1 over 1, right about there. Yeah?
And so then you do that.
How do I go the other direction?
You go
when I
up
need
1
to?
over 1.
Oh, but struggle. Hold on. Wait. Would we call this an uphill or a downhill?
Uphill.
Downhill.
But the slope's negative. Do we do something wrong?
Oh, sorry, you go to the left.
Yes.
When I said down 1 over 1.
Exactly. So we have to be specific or else we're going to get a little messed up. So when we go down 1, we need to go to the right.
Oh, right.
I mean,
Yeah.
the line is going down.
Good.
Oh, I thought you meant. Oh.
Does that make sense? Now it's going to be
You go
downhill.
left, you go up. Yep.
We can always double check with uphill, downhill.
And then if you do it right,
So I'm going to go ahead and go up and over. Up and over. Ooh, that's not going to be straight. Okay, do we roughly have a line?
Yes.
Now question. I need another line, right?
Yeah, it's that.
Okay. So then I think I have a straight mark. Whoa, apologize for the straight mark. What do I do with the green one? Where do I start?
2.
Up to. Make a point. What's the slope for an x if he's all alone?
1.
But
Oh,
positive
but
one.
it's positive, you go uphill, right? So up one over one.
Right one, and then you go down, left.
Cool. Now, what's the struggle with graphing? Why is he sometimes hard?
Because you won't always
That's
line.
confusing line.
Yeah, you won't always have a straight line.
Yeah. I mean, you guys just saw my tick marks, my whole graph is a little round,
Better
right?
than your phone.
We can see the intersection, but how are we going to know exactly where it is? Or could we guess?
Yeah.
1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 6. I don't know. It kind of looks like -6, -6. How do we know if that's right or not, though?
You plug it back in.
We plug it back in. But if we go to plug it back in, -6 plus -6 doesn't work.
So could we do it like that?
-6, -4.
Right? It's -12. Now, are we close?
Yes.
Can we try -6, -5?
-5, -5.
-5, negative. Oh, maybe I was off, right? Okay, so if we were to guess and say, you know what, that worked on the first one, let's try the second one because it has to work in both. Hold on. What's -5? We have to test it, right? What's -5 minus -5? It's not going to work. Now here's the struggle. The actual answer, I believe, would be -4, -6. Nope, switch it. Switch it.
Yeah, -6, -4.
How'd you back me up? How do you know?
Because it equals 2. And I mean -2. Yeah.
So we could do -6 plus -4. Now guys, why is this not a very good method? Why is it not very precise?
It takes a while. And you don't hear
Yeah, right? Like I skipped some steps and I kind of had one answer and I guessed a couple other answers. Like that's horrible for math. Who wants to be guessing stuff, right? Now wait, the nice thing is, in your 5-1 to 5-4 quiz in your book, they draw the graphs for you.
Oh, yes.
Oh, well it's going to be precise. It's going to be perfect, right?
Yes.
And then if you were to use graph paper, then you could be perfect too, in the sense of your graphing, if you were to make it all line up and have your slopes be measuring up okay. So graphing can be good, but it also can be kind of imprecise if you don't have graph paper. True? Still a good method, but not necessarily the best if we have an option to choose. Now, what's going on with substitution? New example. Let's go ahead and get it down.
Choose it. Just choose it.
Substitutions. I always go back to the silliest of the Glade commercials. The little jingle. Plug it in, plug it in. Think about air fresheners, or if you're thinking about math. Substitution. We're plugging it in. What? I don't know, something. Why is this a prime example for substitution? This one's perfect.
Once you solve the.
Oh, because you already have
bottom
X.
one, you already have the one.
Good. We have two variables in both, but we already have one isolated. We already have one alone. And what's the whole point of substitution? You get one variable alone.
Yes.
You take who he's equal to, and what do you do with it? And the other
one.
Plug it in, plug it in.
This is y minus
Is it?
3
Yeah.
raised to 2y minus
Yeah, he's already done it. Because all you have to do is say, sweet, you know what? You throw that 3 and then you need a parenthesis, because you did throw in the entire quantity. Who goes in that x spot?
2y.
Exactly. And why was this helpful? Because now we have one equation with, now it's in multiple places, but how many variables? Just y's, right? Now, come on, algebraic kiddos. We can do this. How do you simplify? Distribute, I like it. Plus, right? Negative times negative.
Negative.
Yes.
It would be 5y plus 1 equals
Positive or negative?
negative 5y. Plus, I mean, minus 1.
Good. Now we're just on it, right? We're just moving everything where we need it to go.
30 divided by 5.
Negative 9 minus 21 is negative 30. Make sure your signs are staying with, or else The bummer is if you have the wrong sign, it just got wrong, right?
6.
Divided by six.
Oh, I forgot.
Now, that's great, but how many at the very beginning were we trying to solve for? Ah. So why is it so great now that we have one?
Because now
I know what y is, and what did we circle at the very beginning? What is that one at the very top?
Y.
A place to put y to get x, right? So now we can take this little puppy and say, you know what, I need you, but where do I need you? Right here.
5.
Are we plugging in? 6. And I already heard some of you mental mathers be like, sweet, 2 and 6, 12, 12 minus 7 is 5, and so we end up with extra comments. Let's come right? Now, what's that proper way of writing it? I did it on the last one. You might not have recognized it. We can say x and y, or we can write it in order here. Now remember, you have options, because you can watch the video later and just write it quick, and just focus in class. It just depends. I have people all the way up in calculus that do that. They just watch the lectures at night and they just listen in class and just get it. But other people are like, nah, it's better if I write it. We've done graphing. We've done substitution. What's the third one? I know, right? The great elimination ones are the ones where you have x terms or y terms that have the exact same coefficient number and opposite signs, because then you just add down and poof, it's gone. The whole point, it's eliminated. But is this one perfect?
No.
But would it be fun to solve for x or solve for y and substitute? Ugh. Right? To get x alone, that looks gross. To get y. So, guys, okay? We don't want to solve for x or solve for y, because that just looks messy. That'd be substitution. We don't want to get y equals mx plus b, because that looks even worse. But we want to make them match, and Johnny was saying like, oh, you multiply one by one and one by another, well question, what numbers do we need to? Let's stop looking stuff. What numbers do we need to multiply? Well, we gotta choose. So, what do you guys think? I'm gonna put a big old huge parenthesis, because parenthesis with the number is like distributing, right? What could I multiply everybody by on this?
2.
5? We could do -5. That would make this -10. This one by 2? Okay, let's do that. Multiple ways of doing it. We could multiply this whole one by 2, because you'll get a 10. And then, why did you guys say a -5? I love it. It was perfect. You need the opposite sign to add down, right? Does that make sense?
Forgot that step.
So now the goal is, what's this called when you're multiplying in? Distribute.
Yep.
It's multiplication, right? Okay. So let's distribute. We're going to have to take him to every single piece, even across the equals. Coach Trapp might have shown it like times on this side, times on that side. Either way is good. What happens for my first term? -5 times 2x. Got it. Next term.
-25.
Plus -25 minus 25, whichever way you find it.
Same equation. I'm gonna use my calculator.
Can I beat you on your calculator? Nice. -80.
Gosh! Oh, I know how to do that one. That was
See it?
Yeah, you add the 0 and
Yeah.
I always.
It's okay. You got it.
Sorry, I'm retarded.
No, you're not. Coming back. How do I do the bottom one? Yeah, I have to distribute again, right? Now guys, hold on. If one part of the process breaks down, if you just totally space out, you forget one, is it going to be right? Now, we have to make sure that everything matches up, right? So what do we get for the x term? Tyler, let's write that down.
Positive 10x.
Positive 10x, then what?
4y.
Y is it now prime? It's ready, it's perfect.
And not the x.
Go down, right? Okay, let's come on. Just add straight down. Now, just because I put a plus right here, that doesn't mean I change all the signs, right? I'm just going with whatever signs are there. So a negative 10x plus 10x,
Crosses each other out.
eliminated. Right? Sniper, figure it out. Then we add down and we end up with,
9.
careful, watch out for those arithmetic mistakes. It's so easy to make, right?
I always.
Negative 29. Negative 80 plus 22. Any mental math? Is that
58.
Woo!
Hey.
Where'd you guys go? Now the nice thing is, now it's perfect because, do you guys know what 29 times 2 is?
58.
Yeah. I didn't ask it weird, like I was thinking of the division.
5.
Y equals,
See, I told you I had the right
now remember, a system, how many variables we're missing?
2.
And we only have one, so what do we do with this guy?
Yeah.
Well, where do we plug it in?
Wherever.
Wherever you want. First or second, where are we going?
Let's go to the first one. The first one.
Alright, I heard the first one most, so let's go there. We have to plug it in somewhere, so let's go ahead and take this 2 and say, you know what, we need to put you wherever the y is. So I'm going to go ahead and say, let's rewrite it, 2x plus 5 times who?
2.
2 equals 16. And we'll plug in 2.
But you're not plugging it in.
Yeah, because it has to be true for both. Yeah, whatever one looks easier.
X plus 10 equals 12. I mean, 6.
Alright, that's the math that you're going for, right?
6.
Yeah.
3.
Minus
10 is 6.
Can I just, can you guys make the jump? Hold on, let's check it.
Yeah.
6? Good?
Yeah.
And x equals?
3.
Now, it's kind of dangerous sometimes to skip steps, but if we can follow, maybe we can make a few things faster. Okay. So then how can we rewrite it? A little order pair 3, 2.
Is bottom of 2, right?
Now, technically there were 4 examples. I'm actually going to cut it right here for a very particular reason, but hold on. I want you guys just to look at the next example. We're not going to solve it, just look at it. How many methods did we just, I'm showing you. How many methods did we just look at? 3. What were the 3?
Elimination, gravity,
You got it. You guys even had Christmas break. I want you to look at this, and in just 1 second, I'm just going to ask you to raise your hand for which method you think you would use out of those 3. Hold on. I'm going to give you like each of them, and I'll just see how many people choose that one, okay? Look at the problem and say, what would I think of doing? Graphing, like what am I supposed to do? Substitution, solve for x or y, probably. Substitution. Or elimination, let's go down, mix, minus, also. How do you guys say graphing? Yeah, right? Substitution. Okay. It wouldn't have been that bad, solve for that one. But elimination. Now, wait. There's a danger with elimination. Could you add down?
No.
No.
Multiply
Multiply by, oh, now we're good.
Negative 3.
everything.
Yeah.
Right?
Yeah.
Then go.
You can't sin.
Okay. Here's what I want you guys to do. That's for later. I want you guys to go ahead and look at the calendar real quick. What was homework tonight? Oops, hold on, I'm on the wrong one. We're at homework number 1. Here we go. Ew. We didn't even get to start it in class.
It's 260 all.
But we got to review it all.
That's.
Let's say since we didn't start it in class, let's just make it odds. Send it? Alright, so wherever you put your homework,
Yeah, sorry,
if you want to already put a heading on your homework, that way you won't forget it. You have it ready to go tonight. Sweet. Just call it homework number 1. I keep track of them by numbering. It's easier for me. So I'll go ahead and show you the assignment as well. But I'm going to go ahead and click and change this thing, yeah? Let's not do long. Let's do odd. Hold on, sorry, I took it off for you guys. Write odd, not all. What do I mean by odd? 1, 3, 5, 7.
It's all odds, right?
Yeah, all the odds, but just the odds.
So like 1, 3, 5,
1, 3, 5, 7, yeah.
And then just all odds.
Every other one, right?
Yeah, this
Alright, sweet. Now it's official. I'm saving it. It's odds.
You saw me? What the hell?
Now hold on, we have a couple minutes. Grab a seat. Hold on, hold on. Grab your seat.
Grab your actual.
It's like the apple of 2.